And without further ado, I want to introduce you to today's session of Improving Track Availability by Rashid Dorj, our senior track engineer from City of Ottawa. Rashid Dorj is senior track engineer in the City of Ottawa's rail construction program and is involved in the design, management, of both of the Confederation and Trillium Line Stage 2 projects. Rashid started his railway career with Canarail Consultants, where he worked on the design of various Canadian and international railway projects. He later was project engineer for Bias, an ACS Group subsidiary, on the construction of Ottawa's Stage 1 LRT project. He subsequently joined the City of Ottawa's Rail Operations Branch, where he planned and managed numerous maintenance and capital upgrade projects for the Trillium Line. He holds a bachelor's degree in building engineering and a master's degree in civil engineering from Concordia University. So welcome, Rashid. I'm very happy to have you here with us today.
Thank you. That photo reminded me that perhaps it's time I was a little bit more honest with my white beard and white hair. Okay, I'll just share my screen, and please let me know if it works.
Fantastic.
All right. Okay, so excuse me. Okay. And
yes, that's perfect.
All right. So we see this screen, correct? Okay.
Yeah.
Well, thank you everyone for joining me today. So my name is Rashid. I work on the tracks for the City of Ottawa's Confederation and Trillium Line, and I'm just here to share some experience, some improvements that we've done over the years. And I want to say that I love the hashtag, the conversation that needed to happen, and I think really this is my goal, is to share the knowledge that we've kind of gathered throughout the years with the industry, and hopefully that encourages others to also share their experience, so that at the end of the day we can all learn from each other. And then so the theme, improving track availability, really is to make sure that the track is available as much as possible for the train service, for revenue service. And the theme is about optimizing, establishing optimizations around repetitive tasks and expected failures. And these expected failures occur either over time because they're being used and used and used, or due to weather. So this is the content. I have I think 24 slides. I'm hoping to go through it quickly and then leave some time for question and answers at the end. And then so for those who are not familiar with the City of Ottawa's O-Train network and its expanding O-Train network, I'm going to cover that. I'm going to discuss the Ottawa weather, talk about track access, switch heaters or switch clearing devices, switch rollers, preferred rail lane temperature, ballast conductivity, wheel and rail profiles, snow storage, fence, and tree cutting. And so some of this experience comes from Trillium Line, and some of it comes from Confederation Line, and really I think the purpose is to relay that feedback so that the industry comes up with better solutions, better than what we've kind of adopted, or actually investigates how to improve those issues. So the O-Train network, there's two primary lines. In red, we call it the Confederation Line, internally known as Line 1, and then the green, known as a Trillium Line, known as Line 2. So the Confederation Line is 13 kilometers, double-tracked, electrified. It's a system that just came in operation in 2019, maximum 100 kilometers per hour track speeds. The train is automated. In other words, it's the train control that kind of controls speed and whatnot, but there is an operator for redundancy in the train cab. And based on the train schedule, it should see about 30 to 35 million gross tons per annum. Trillium Line This line is a bit different. It's a pilot project that started in 2001. The city purchased the old train tracks from CP, and then from a pilot decided to launch an LRT system. And then so the initial Trillium line was 8 kilometers. We're expanding that to another 16, so adding twice as much length. And that train system is it's a DMUs or DEMUs, so diesel multiple units. City started off with the Bombardier Talents in 2013 and decided to expand the fleet. Bombardier got out of the diesel multiple unit business, so the city looked at other vendors, purchased the Alstom Linz, and now as part of the expansion projects, for the Trillium line, where we purchased Stadler Flirts. And then so the train speeds are 85 kilometers per hour, but the line speed is much higher than that. And in launch as part of the stage 2, we expect to have 15 million gross tons per annum. I'm just kind of giving you that idea so that you can compare that to the products that you work on or the products that you maintain and so on, just to kind of give you an idea. 2 different kind of LRT systems. They're both light rail, but very, very different in terms of maintenance. So the bulk of the experience comes from the Trillium line. And then Trillium line is it's an old freight line. We inherited 2 diamond crossings, and I don't mean diamond crossers, I mean diamond crossings. And for those who probably don't know much about a diamond crossing, it's like riding a Ferrari, which is the LRT system, on a highway with unavoidable potholes in the center. It's a real headache. It's a whole different level of maintenance. And in terms of the staff, we had rail term today Siemens, who had 1 maintainer during the summer days, turned to 2 maintainers during the winter. Generally speaking, 2 signal maintainers. In terms of the city staff, technical city staff, there was 1 manager, 1 track engineer, 1 vehicle engineer, and 1 project manager. And that's not considering the operations staff like the superintendents and whatnot. So Ottawa weather. So the photos you see on the right, these are not from locations such as Oklahoma that you hear. These are taken from Ottawa in recent years. And so I wanted to discuss how we sometimes look at average for coming up with a design, but how the new extremes are actually important. So on average, the city in January sees -7 Celsius during the day, -14 at night, only 5 days of snow. In July, we see 25 degrees Celsius during the day, 15 C at night, and only 8 days of rain. If you look at the average extremes, we're looking at only 11 days of +30, only 16 days of -20, and 224 centimeters of snow annually, which is 88 inches. And now that doesn't seem that bad when you look at it, right? Because when you're thinking average, you're looking throughout the whole winter season or throughout the whole summer season. But in the new extremes, January 17 of 2022, in 1 day alone, we had 48 centimeters of snow. That's 20% of the average in a single day. In a single hour, 12 centimeters of snow. Okay, so that becomes an important subject, more in discussion when certain, let's say, a green track is proposed and how that would actually function in terms of snow storage. Tornadoes or I dare say hurricane-grade windstorms, or we're just talking about heavy windstorms, are occurring every 2 to 3 days, 2 to 3 days, 2 to 3 years. Just in August, we had a single 48 hours of 112 millimeters of rainfall. And then so when you're looking at the usually target of 98.5% reliability, it's a good target to establish. That gives you 5 days of failure. That doesn't consider passenger disruptions, because they do occur. Doesn't consider rolling stock failure. That doesn't consider track failure not due to weather. We're talking track failure because of excess use. And then so these are not unique problems in Ottawa. They're occurring nationwide. They're just to some other degrees, such as the Western Canada. So I'd like to talk about probably the first point. So what I do is I generally go and talk about Trillium line, what was done in the Trillium line and what allowed us to meet really, really high track availability percentages, and what I recommend as a best practice. So that's kind of my opinion based on my experience. And then for each agency, or organization, is to determine whether it works out for them or not. So Trillium Line, generally, we had the Walkley Yard train, the maintenance of way vehicles would high rail at the Walkley Yard. They were already high railed in anticipation of the last train coming off the line. As soon as the last train came off the line, the truck was already high railed, ready to move in and do weather inspections or maintenance. And so this allowed to maximize the very little small engineering hour windows that we had. And we're talking very small. We're not talking about an 8-hour block. We're talking just a few hours. Sometimes considering staging during the week, staging on, staging off of the trains, 2 hours of work window or so. So the level crossing length was sufficient. The truck didn't have to reverse and go forward 100 times before they can actually high rail. So it was long enough for the largest maintenance of way equipment. And there was level crossings on both extremities. So the entrance point was at the yard, and the exit point was at Walkley. It was at Bayview, which was the other end of the line, and it allowed the maintainer to get on, perform inspections or repairs, and then get off at the other end. There wasn't an intermediate point where they had to, oh, we need to go back now. We'll do the rest tomorrow. They were able to really make use of the access as best as possible to take every single minute for maintenance work. And then so my recommendation when it comes to track access, right, is that you maximize the length of your level crossings, allow for an entrance and exit point, so that your maintainer doesn't have to get off in the center of the guideway, so that they have to kind of separate the chunks of track. You never know how that kind of comes into your benefit by adding an extra one at the end. If you're going to put a level crossing, my recommendation is consider your vehicle length, and don't consider the high rail pickup. Consider, for instance, your Holland truck, which would be your heavy geometry inspection vehicle, and then add a panel on each end so that they're actually able to high rail easily. If you're going to be adjacent to the track, in other words, you don't have a yard to get off at. Use a double cantilevered gate such as the one on the photo on the right. Basically, you don't have to remove, the alternative to this is a swing gate, which forces the maintainer to clear the snow on the inside and the outside. And then that just kills the time that you have for doing track maintenance, just accessing. And then so I did a quick math, all right? And based on my experience, double cantilevered gate would save you 3 minutes for accessing versus swing gate. So if you just did 3 minutes, that's 3 minutes of access, unlock, access, high rail, and then the same thing back. So that's 6 minutes per shift. On a 2-hour engineering shift, that actually represents 5% efficiency. And if you did the math of that, take 2 track maintainers, 1 high rail truck, the charge rate for that, you're looking at $150 savings per shift. Okay, the price difference is probably $10,000, and then so you're looking at a return on investment of 3 months. So it's almost, I'd say that a no-brainer to really consider access when it comes to helping out your track maintenance staff. So the next subject is track heaters, also called the SCDs, snow clearing devices. On the Trillium line, we had 2 styles. We had the natural gas. Wherever we had access to natural gas, we would have installed natural gas, and wherever we didn't, we put in propane. And then the model was the Hovey Hellfire, which is today owned by Therman, and it's a hot air blower. It's just like the photo you see on the right. It's the heaters on the outside. You have 2 point nozzles blowing hot air at the point rails, and then you have these center ducts that are clearing the slide plates entirely all the way down. And then on the left is what you actually have when you don't have a switch heating device and you actually have to clear it by hand. Okay, the snow is removed by hand. And then so you have ice formation, you have, it's quite the headache for a maintainer to kind of go at it, pick at it with a pickaxe, try to remove the ice. And in terms of natural gas, it's a substantial saving. Based on the math I did I think about a year ago, it was about 15% of the costs. In other words, if it costs you $15, you'd be paying $100 for electric or propane. So there's definitely advantages if you're looking to operate the line 20, 25 years. There's absolutely savings in there, considering the construction costs of bringing in natural gas. So again, propane is almost similar to electric in terms of heating costs. And then what we have here is Confederation mainline. I just wanted to discuss the Confederation, what it uses, because Confederation used the stage 1 used electric heaters. And then so the electric heaters only rely on a point nozzle. I'm sorry for the photo, but basically there isn't a center duct. It's just these 2-point nozzles that are shooting hot air. It's a 45 kilowatt hour unit. And yeah, again, it relies on point rails. And so the unfortunate issue was that sometimes the point rails, the slide plates weren't cleared by the nozzles at the end. They just didn't have enough heat, didn't enough airflow to reach there. So the upgraded versions for the Confed, it's kind of combination of 3 that have been looked at. One is a heat trace cable. It's basically on top of the switch heater with the point nozzles. There's a heat trace cable that runs alongside the stock rail, and it's actually worked decently in certain locations. If not, there's a center duct that's installed. This is a custom center duct that's made for this particular switch, and it basically reaches as many slide plates as possible so that there isn't snow or ice jammed preventing the point rail from going into location. And as well, another solution that was looked at was switch heater covers. And these had limited success, and some of it was not necessarily due to preventing the snow from getting to the plates, but it was more about how it impacted the mechanism of the machine. And then so for the stage 2, we're going entirely with propane and natural gas whenever we can. Certain locations of the stage 1 will actually have propane and or natural gas. And then they'll look just like this. Again, point nozzles, the point rails are here. You got a center duct. This is a heater duct that goes into the unit. And the unit here has either natural gas or propane connection. And again, I put plus 400,000 because I'm not sure if the 400 or the 900,000 BTU models, but the equivalent in electrical is 120 kilowatts. So it's substantially more. And so in the natural gas equivalent, it'll save the city substantial amount of energy costs. Jumping into switch rollers, and I think this is probably, I'm going to say this is a presentation on its own, because there's just so many different angles to it. So for those who don't know, a standard slide plate for a switch, this is the stock rail, this is the point rail or the switch rail we call. There's these slide plates, these are lubricated, and then basically the point rail moves back and forth and it relies on lubrication to prevent over force on the switch machine. And then, so you need lubrication. An important thing to consider is that lubrication, based on the experience on the Trillium line, it evaporates at a different rate in the summer and winter. So your type of application, your frequency application is different. On average, my experience is that we lubricated the plates every 3 days. And that depended on the state of the switch. If a switch had vertical problems, and you see like here where it was excessive rubbing, then you need to pay a little bit more attention and apply more lubrication. This is kind of the mechanism, this is a slide plate. I just did a quick cross section, even though this doesn't apply actually to Trillium line. And there's also discussion of using graphite grease. Graphite grease works awesome in a theoretical sense. When you look at the practical use of it, you see that it's not always ideal. And then so I'm going to say that it's unfortunate to see that some major new LRT projects from the US and Canada are still relying on slide plate lubrication. And it's unfortunate that they haven't actually looked at switch rollers, because it's so many different benefits. But there are different angles to it. There are different applications to it. And the So the general theme when you're looking at choosing what's the best roller, you need to determine whether you have an ARIMA style point rail or an EU style point rail. ARIMA point rails, it's sort of like this. It's got a reinforcement bar in the center, and it leaves you with these holes. If you have an EU style, it's a section that's on its own. It's basically carved. It's only used as a point rail. And then so you also have to look at whether your switch is heated or not heated. Those impact your choice. You have to look at whether it's a brand new or it's a retrofit installation. And then so there's generally three styles of it. Okay. I'm going to say two styles and then a third one that's completely on its own. There's the plate rollers, which are this style. It's basically a plate swaps out the existing slide plates. It's a plate that's usually twice the thickness. Shuihag is probably the most famous in terms of name. Voestalpine has the blue roll. Vostell makes an equivalent. I think this is probably a Vostell cross section, but they look more or less the same. Okay. The other is an echo slide. We use these extensively on the chilling line, and basically it's a point rail, so it's attached to the point. You put in longer bolts. You put this little bracket with the roller under it, and then you put the bolts back on, and it looks like this. In this case, I believe this is a number 11 turnout. So you have 3 sets, so it's a total of 6. And then you have the delta switch, and the delta switch works completely different. It's almost putting the point rail on a pendulum. So this is a cross section. This is the delta switch where it would install. It goes in between the two ties. And the moment that the point rail is forced in, the point rail sits on a pendulum, and then it throws on the other side. So regardless of which one you were to look at, you're definitely going to see a reduction in your current draw, so the amount of power required by a machine. It's a consistent current draw. So in other words, in winter, in summer, based on the lubrication's performance, you're still having the same amount of current draw. And then, you don't have to worry about a contaminated ballast or a slip hazard. I mean, anybody who's worked around switches, you see how it gets dirty. It could be a slipping hazard. You have to be careful how you walk around, and it's not a pretty sight. And I'm going to say I find it puzzling that I see sometimes this discussion and talk about environmentally friendly lubrication. Let's adopt a green lubrication, or there's a company called Railway Robotics. I saw this on LinkedIn. They're developing an AI for automatic lubrication of slide plates, and it to me is just baffling. Why not look at slide plates? It can't get more of a greener version and a more consistent solution for switches. And again, I did a quick cost comparison based on my experience. When they were to be adopted for trillion line turnouts. The plate rollers are probably the most expensive. It requires lowering the tie, so that requires more effort. It requires putting in brace plates, but still, a set of 3 costs you $20,000 per turnout. Point roller are less expensive, $6,000 for a set of 6, and then the delta switch are $3,000, and they each kind of require their own maintenance. It's not one approach will fix it all. Okay, you really need to look into it. There's different implications in terms of the way they're installed, the impact, maintenance, but I can guarantee in every single case the return on investment is guaranteed. So in terms of the most expensive, we adopted them on Trillium Line because we used our switches 184 times a day. Okay, that's 184 movements because it was almost entirely single track. And when you consider 184 movements, your switch gets worn. It starts having consistent issues. So you need to really make sure that you have everything on your side in the sense that you're avoiding failures. You're forecasting when things go bad. So even in the case of the Shuiags that we implemented, based on a quick calc, it's a 5-month return on investment. The point roller is 1.5, and then the delta switch less than 3 weeks. So in all cases, you have a reduction in the current draw. The maintainer can actually focus on doing track maintenance instead of saying, you know what, this day of the week, grab my bucket, and I'm going to start going and applying lubrication on the slide plates. And it just, allows the maintainer to focus on the inspections or fixing other things, and you don't have any issues with contaminating your ballast at the turnouts. And I hope that by the time that I retire, we'll talk about switch slide plate lubrication as we speak today about steam trains, a thing of the past. I'd like to talk about preferred rail laying temperature and what really worked well on the Trillium line. So Trillium line we inherited a CP practice, which is a freight practice. The fastening system. Don't be fooled by what you see on the right here. This is a photo taken during construction on the Confederation line. It's not even during operation. It was just to show you what a buckle would look like, really. So for those who are not familiar with it. But on the Trillium, we our range was 30C to 35C. 32C was the preferred rail laying temperature. And the preferred rail laying temperature shouldn't be confused with what I hear a lot of people say, de-stress temperature, because the practice in North America, Canada, and the US is generally to put the rail in tension. So we actually stress the rail. So 32C was our stressing temperature. And it meant that most of the year, the rail was in tension, right? And I'll go in my next slide, I'll explain some of the math to it. But the system was coupled with a rail brake detection system that ran on 18-volt DC, and it's a current across the rail. And the moment that the rail breaks in the cold winter, if it did, the rail brake detection system would flag and say, hey, there's a rail break. You need to look at it. So up to to the best of my knowledge, I haven't heard anybody tell me there was ever a rail break on the Trillium line, and it's 19 years of service, 17 years of CWR service. There was instances where we captured discontinuities, so defects, rail defects with ultrasonic, and we cut those out and put a brand new plug. And there was never any track buckles like you see in the photo. There was occasions of wavy rail, but never a track buckle. Now, I wanted to just do a quick math, because I think in terms of best practice, when you're looking at your agency or your project, probably something to consider. You need to know your buckling temperature. You need to know your brake temperature, okay? Based on the literature review, and I'm happy to have a conversation in depth on this with anybody who's interested. So the rail temperature, on average, based on my experience on locations that have direct sunlight, is 25 degrees higher than the air temperature. Buckle temperature is 40 degrees above the preferred rail laying temperature, which meant that for Trillium, it would have been at 72C. So if you just worked your way backwards, say, well, at what temperature would the track possibly buckle? And that's a poorly maintained track. You're looking at 47 degrees Celsius. So the hottest temperature we ever got in Ottawa, recorded, is 38. I'm convinced that eventually we'll reach mid-40s based on the weather patterns that we see today. But I think the lesson here is that you can't implement the best rail laying temperature. You need to be on top of it. You need to adopt IoT devices for understanding the correlation between your rail temperature and your air temperature, like the 25 that I discussed earlier on. If you can, in your design, avoid anything less than 184 meters as per TCRP. If you can't avoid that, change the track type from ballasted to something a little bit more rigid, like direct fixation. If you can't do that, then go in and consider track anchors like you see on the photo on the right. It's anchors that go deep in, and they do a pretty good job of holding the track in place. And ultimately, you need to consider that your rail needs to be re-stressed, okay? You can't think of stressing the rail once and then forgetting about it for decades, okay? You need to look at the rail eventually. If it starts resulting in brakes or speed restrictions because of wavy rail, then you need to revisit re-stressing of it. So the performance of your PRLT is inversely dependent on the number of rail brakes and track speed restrictions. So a couple of subjects I wanted to just kind of best practices. Wasn't necessarily an issue on Trillium line, but it's been an issue that we've implemented on our stage 2 projects. It's ballast conductivity, and that's a problem for electrified track. It's, to my knowledge, ARIMA and TCRP 155 are not prescriptive on this, but it is definitely a problem on every single electrified track. They have a problem with straight current. And usually the means of it is obviously you insulate the rail, but when it comes to the ballast, you clear the underside of the rail and make sure that the ballast and the rail never touch each other. But it's impossible, perfectly impossible. Okay. The photo I took on the right not long ago, it's sometimes you get a can that gets under that, and it, believe it or not, results in substantial current loss, and current loss equals material loss due to corrosion. So if your track is electrified, definitely test it for conductivity. CN has a great standard for that, 1220C, and you basically test your ballast for less than 3,000 ohms meters. All right, Trillium Line had multiple wheel and rail profiles that were developed by the NRC, the Natural Research Council of Canada. And so the rail cant, because it was CP, was a 120. The wheel was a 220, which actually had a 120 general thread profile. The super elevation was capped at 75 millimeters. And then so the NRC developed various profiles, right? They developed 3 tangent profiles. They developed 1 high rail profile and 1 low rail profile. I kind of put them, I mean, they're very difficult to tell the difference, but I can tell you that they're different. So our target on the Trillium Line was we took the 3 tangent profiles and we split those evenly by 3 across the tangent sections. Wherever we had shallow curves, we adopted a different tangent profile. Wherever we had sharp curves, we developed a high rail and low rail profiles. And we implemented those via profile grinding. You know, we gone through with a rail grinder. And I'm going to say that, to my knowledge, I have never seen RCF on the Trillium Line on the years that I worked on it. And so I attribute that success to the good match of the wheel and rail profiles together. And then, but occasionally we did implement rail preventative grinding to remove corrugation that we had at our sightings, because the operators will break always at the same location. So my suggestion to the industry is basically understand the application of super elevation. Do not maximize your EA, which is your actual. Don't maximize your EU, which is your unbalanced. Know the difference between when it's human operated and software operated, because they work differently. I mentioned it earlier on. Try not to maximize the minimum track radius. I know the train manufacturer says they will operate at that speed at those curves, but there is a huge maintenance implications to it. And as a designer, you have it's important to know that implication. So I think, based on my experience, you know, there's 2 things. You absolutely, if you operate light rail systems, you need to have rail profiles. You cannot expect to have a single uniform profile across your network and get away with any RCFs. If you do, I like to meet you. But yeah, it's because the concrete ties, the direct fixation, hold the rail at the same location every time. So you don't have gauge widening like you have with timber ties. So your wheel is running at the same location every day and night. And then so you're increasing the stress levels, you start having cracks. So that's really, really important to understand, that you won't be able to get away with a single profile. And at the same time, I'm going to say that you need to have in mind that you need to do preventive grinding to remove RCF or corrugation, and also to maintain your rail profiles from wear. I know that I'm going a little over time, but I'll just quickly go through this. Track centers is probably something that's really, really overlooked. A lot of times they're developed based on the envelope of the trains. But in terms of the Trillium Line, we had very little issues with snow storage. The distance between the 2 tracks, this is a Brookfield siding, was in excess of 5 meters. It's difficult to tell from the photo, but the regulator was able to plow in the center on the side with no problem. And it was instances where we had a freak snowstorm. The city was shut down, but the train, because of that ability, the train was still operating. And then so the induces as well, this is a passive train control, was on the outside, wasn't in the center, so allowed the regulator to remove the snow storage in the center of the track. A lot of networks have it in the middle, and that kind of does pose a problem where you have to remove snow by hand. So the best practice, I'd say, is, you know, try to avoid a scenario where you're putting it close. I know sometimes real estate doesn't allow you, but be mindful that it does have an impact in terms of snow storage. If you're going to have a ballast profile between two tracks, make sure you know how you don't level off the two tracks ballast profile, the 2-to-1 slope. Leave your 2-to-1 slope in the middle so you actually increase the capacity. All right, I'll just go quickly over these. The fence on the Trillium line was again, it was a freight corridor. Freight corridors usually have a very wide right of way, so the railway put the fence line as far as possible. That allows the inspection during the day, so it allows us to do inspections during the day without seeing the train, without impacting train service. So sometimes I would show up and look at the train go by at a specific location that was an issue. If the fence was adjacent to the track, I probably wouldn't have been able to do that as well. Tie placement and disposal and replacement was permitted in these instances. As you can see, this is a tie replacement project a few years back where we kind of laid the ties in between the shifts, between the overnight shifts. It allows for vegetation clearance and also allows the operators to see trespassers in advance. And so sometimes when you go through ballast renewal is an inevitable process of a track. So 100 to 300 million gross tons, you're gonna have to do this. So if your fence is adjacent to your track, you won't be able to do that. So just be mindful when you're considering that you look into the cycle. Do you really want to remove the fence from one end of the alignment to the other when it comes down to doing ballast cleaning? And so I'd say that again, another subject on the fence that helped as well was that because the fence was on the outside, when it came to our tree cutting, whenever we had a tree fall from a major windstorm, it wouldn't fall on the track, or it was less likely to fall on the track. So, we had one instance where we had a major tornado. We had a bunch of trees that fell on the track, and we said from now on we're going to survey every single tree that's at risk of falling on the tracks. We prioritize cutting on an annual basis, so we cut down anything that was at risk. And I remember that was following that program, the following, like it was a storm that happened a couple of months later, and it was, bunch of trees all over the city that had fallen down, but not a single tree on the tree line had fallen down because of what had happened from our work. So apologize for running through it quickly. I'm hoping that this presentation was insightful, that it kind of it brought about questions to anybody or instigated questions, and I'm happy to continue the conversation either in the QA period or even afterwards after this meeting. Thank you.
Thank you so much, Rashid. I received a question when you were presenting, and there's a few people that have their hands up. So let me start with the first question that we received. Jihad asked, is one pair of delta switch sufficient for a number 20 turnout?
That's a good question. I'd have to look into it. Yeah, that's a really good question. I think there is an implication in terms of if you have the throw rods, brace rods, I'm forgetting my words, the rod that holds the 2-point rails together. So there is an implication of where that's located and where you place it. But I think I can definitely look into that and see if I can have an answer. I'm interested to know as well.
Good. Great question. And we have a list of people here with their hands up. Mohsen Yazdi was the first one. Let's hear it from you.
Yeah, hi everyone, and thanks Rashid for the great presentation. So you mentioned that the PRLT in Ottawa, I just want to double check. So it's set at 90 Fahrenheit, 32 Celsius. That's the Ottawa PRLT.
That's the Trillium line PRLT. I didn't want to take time in the presentation to go over the practice adopted on the Confederation line. So the Confederation line, because there's a mix of different track types, there's ballasted, there's also direct fixation, there's a multitude of structures existing before the line came into service and afterwards, while, for construction. The practice adopted on the Confederation line was to even out the compression and tension forces. So it's actually 10 to 20 C on the Confederation line.
Okay.
But the Trillium line ballasted track is in the, it was 32. The stage 2 Confederation line, it will be adopting a 25 to 25C range, so it's a bit higher than the stage 1. But we are, it is a bit different. We are using W clips versus E clips. There's a couple of implications. It's not necessarily apples to apples comparison. But
Okay.
Trillium line, yes, it was 32C.
Okay, thank you. And then I have one more question about that the wheel rate profile. If you can go back to the slide. So one thing I couldn't quite get was that. So you mentioned that you had used the different rail profiles, like the rail was like the, let's say, 115 section was grinded to fit the wheel profile in different sections of the track.
Yep. So it was all 115-pound rail. I think it wasn't even a head hardened rail. It's a soft rail, if you like, from 2003. We adopted 3 different tangent profiles. So the 115-pound rail was shaped so that they're like that. I'm gonna say that if track engineering is a niche of civil engineering, rail engineering, that itself is the absolute gurus of that field. So it's a niche within a niche. My understanding is that you have to avoid a 2-point contact. You have to make sure that you're spreading out you're distributing the pressure on the rail to a certain extent. So what they do is that they kind of just send the contact at various locations, and that helps to avoid wheel hollowing. So that was an issue for us. We had instances of wheel hollowing, so we had to maintain the profiles.
So in future, when the rail needs to be kind of replaced, so there's like it's been basically like it's been recorded what section of the rail profile needs to be, like, to what section it needs to be grinded when they want to replace the rail.
Yeah. So you're and then the differences are very minimal between them, but it's enough to send the contact location at a different location of the rail, right? So if you have concrete ties and your gauge barely changes except for wear, your wheel and rail always contact the same location. And then so if you have kilometers of that, what happens is that your wheel starts hollowing, and your rail, it's running at the same location, you start having extra pressure at one location specifically. So you need to develop different profiles so you relocate the contact patch.
Interesting. Thank you.
Yeah, it's probably not so much of an issue on heavy axle because the failure mechanism for the rail is mainly from wear. But for light rail, RCF is a major problem. Yeah.
Okay. Thank you.
Thank you. We have next on our list, Bash Fawal. Go ahead.
Yes. Thank you, Rashid. That's very insightful and very good presentation. A quick question about the wheel and rail interface. So as you know, in the Confed and Trillium, we have outside and we have tunnel. How the temperature of the rail would compensate for the wheel profile in the tunnel would be maybe less cold, and then under the sun would be hotter temperature. So is there a way to compensate those rail profile into underground and above ground tracks?
So if I understand your question, it's about the PRLT, right? It's about what practice to adopt in the tunnel and out of the tunnel. That's a really good question. I think generally the industry doesn't even de-stress the re-stress. I have a bad habit of saying de-stress, which I don't like, of re-stressing or just placing the rail at the temperature that it's installed at. But I think it's easy to determine what's the median, right? Because in winter in a tunnel it can get really cold, and in summer it will get warm but not hot like outside. So if you just chose your median, that would work just fine. But if you looked at the buckling temperature, that's a ballasted buckling temperature, which is never going to occur in a tunnel. So in a tunnel you have to just worry about whether you accidentally put the rail really, really hot and it gets really, really cold. But because it's direct fixation, I'd say that it's probably less likely to occur. But that's an interesting question. I actually haven't given much thought in terms of what's the values that are adopted for tunnels.
Thank you. I appreciate it.
My pleasure.
That was good. And we have next Arash Barsagar. Go ahead with your question, please.
Thanks, Andrea. Thanks, Rashid. It was a great presentation. I don't have a question, just a comment. I would like to just say that, the presentation was very much in line with our mission statement at TRACCS. And this is one of the main reasons, the association was created, to get the conversation going and have these technical discussions. And really appreciate yourself and City of Ottawa coming forward and sharing the great lessons learned, because in the long run, we feel it will help the industry to improve future projects. So we would love to have you back again. If there is other members of your group that have other lessons learned in different areas of the project, we would love to have you back. Thanks for your time.
Thank you. Yeah, I hope that this our experience encourages others to share their experience, because our experience are shaped by what we've seen in the past. So there's a ton that we haven't seen, and it'd be nice to see what our practices adopted, for snow clearing, for PRLTs. It's definitely a discussion right now. It'd be nice to see how different agencies or different engineering firms are solving problems that may come our way down the road.
Yeah, we will definitely try to contact other projects to do the same. But this is a good example of how lessons learned can be shared, and it will help everybody in the long run. So we appreciate the presentation.
Yes, I have one more question. What would you say is the single best improvement that has increased track availability just on its own?
Hands down, switch rollers. I cannot stress that enough. So we had 184 movements a day. We had the Ansaldo STS M23 machine. It's a powered machine, but it can also be operated manually. They're not meant for that level of wear. So we had excessive amount of use. We had disruptions because the machines were just, you needed to replace components. And it was sometimes a $5-10 component put out the line for 2 hours. It was, it was an embarrassing scenario for the public, because the public relies on the system, and it's our objective to make sure that they can rely on it. And then so we even installed at one point I didn't want to discuss it so much in the presentation, but there's these devices, POS systems. They basically attach to the machines, and they are able to detect the amount of draw, a current draw that the machine requires, and they're able to determine whether there's an issue with it. And we had problems with that. We had sometimes so like, because switch machine failures was on our number one failure, we absolutely saw the biggest benefit by adopting switch rollers. And then in our stage 2, there are nice lengths of it that were still in single track. So we've made it a requirement in our PA to have every single new switch needs to have a roller. So in this case, it's not a retrofit like we did for the Trillium line. In this case, our brand new switches have all rollers on them. And I'm maintainers gonna love it, because they don't have to, like I said, literally carry a bucket of oil and spray it. So I'd say hands down, switch rollers was the biggest benefit from the get-go. And then it was definitely working with the Siemens team, Railterm in the past, to develop that and implement it. So that was a big help.
Thank you so much, Rashid. I don't know if you've been looking at the comments, but you have a lot of very positive comments about it. Great presentation, very interesting, very thorough. So thank you really so much for taking your time to help us all as part of the industry. I want to remind everybody that the recording of this presentation will be available to our members. And so join TRACCS, traccs.ca/join-TRACCS. The link is also in the chat. If you don't follow us on social media yet, here's your chance. Please go online and see what we're up to. We have some events happening right now. In 2 weeks, as I said, we have a golf tournament, and you can register at traccs.ca/golf22.
So can I just interrupt with that one? Sorry,
Yes.
and thank you for promoting that. One of the things that we want to do and encourage is anyone who doesn't have a foursome, let's say, and just wants to join and be part of the association, we'd be more than happy to pair you up with other singles or partners that are there. So if you're still interested in networking and exploring the industry, we'd be happy to pair you up as best as we can with the attendees.
Yes, that's right. And don't be shy. Email us if you have an idea. If you want to make a presentation about something that you think could, like this, benefit our membership. As I said, join us on social media. You will have information about everything that's coming up. So here on screen, you have our social media handles, and you can go on traccs.ca and it will connect you to everything there. Thank you very much, everybody, for being here. Thank you, Rashid, again. It was lovely working with you and listening to you, and fantastic. Now, last moment for any more questions.
I'll also ask the audience, seeing as some of them have remained, if you do have suggestions on other workshops, we're more than happy to engage and share some ideas and thoughts. So please email Andrea or myself or Arash with ideas that you have for future workshops.
Yes, my email is now in the chat, andrea.r@traccs.ca. And if you forget it, info@traccs.ca, simple and easy. Arash? Okay.
You want my emails?
No, I just saw that you had raised your hand.
No. I'm done. It was a great presentation, and yeah, we look forward to more of these discussions in the future.
Thank you so much, everybody. Have a wonderful rest of the day. Talk to you soon.
Thanks.
Bye.
Thank
See
you.
Great work, Andrea.
It was a good presentation. It was
Yeah.
really good. Rashid did wonderful.